There are a lot of decision-making scenarios that require more than two pathways to take. Like for our student grade application, what if the student was sick and did not attempt the exam? We might want to reschedule the exam and print out absent in the report. But right now, we only have the option to pass or fail the student. So how can we build off our if-else statement to include more than these two options? Well, that's where the else if comes in. The else if comes after an if but before an else statement, and it checks a different test condition than the one in our if. So instead of checking if the student was passed, our else if can check if the student was absent, and it provides another decision pathway which is just an alternative set of instruction. This will only execute if our previous if test condition is false. So when if passed is false, our code will go to our else if, and if its test condition is absent is true, then we can print out absent, and that's our another decision pathway. Now only if both of these is passed and is absent conditions are false, our code will go into the else code block and print out fail. Let's see what this looks like in our Java code. So here's our Java code with else if. The first thing we need to know for our else if test condition is if the student was absent. For that, we have a new variable is absent, which is a boolean, and it would be either true or false. And then we have our else if after our if but before our else statement. This checks the test condition is absent. So if the student is absent but not passed, we'll enter our else if and print out absent. And now we have three decision pathways we can take. One, if the student is passed, this prints out passed. Two, otherwise, if the student is not passed but is absent, this will print out absent. And three, if none of these conditions are met, it will print out fail. So let's try this out. First, let's consider what happens if is passed is true and is absent is false. In this case, the value of is absent won't matter, and we'll see why that is in a moment. Now that we have these boolean values, the computer will go through our decision-making code line by line. It first gets our if statement and checks whether is passed is true. It is in this case, so we'll enter our if block of code and print out passed, and this will complete our code. That's all that will be printed. Our else if and else statement will be skipped entirely. The value of is absent will never even be tested, and that's because once the computer executes an if block of code, like it did when it printed out passed, it will skip down to the very end curly braces of our last else. And for this code, that's the end of our program. Now what if we switch these boolean values? So is passed is false and is absent is true. The computer will start again reading code from the top and first read our if statement. It checks the test condition whether is passed is true, and this time it isn't, so it will move down to our next code block, which is our else if. And our else if checks if is absent is true. In this case it is, so we'll enter our else if code block and print out absent. Our else statement will be skipped again just like it did in the last example, and that's because once the computer executes an else if block of code, it will again skip down to the end curly braces of our last else. It means that even for longer series of checks with multiple else if statements, only one of their enclosed block of code will be executed at a time. The code block that belongs to whichever test condition is met first. Only if both of these conditions will be false, only then our computer will reach the else statement and print out fail. So if is passed is false and if is absent is false, that's the only time that we reach our else statement.